In this video, we're going to be discussing the methods by which you could prove triangles are congruent to one another. So there are 5 methods for proving triangles are congruent, and we use letters to abbreviate them. So they are side, 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 SSS, side, angle, side, SAS, angle, side, angle, ASA, angle, angle, side, AAS, and hypotenuse-leg, HL. Let's examine what each method looks like below. So a sample is shown for you. In the last column, we're going to add our own markings to represent the given method. So first, if we take a look at side, 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 the key is that when we take a look at that, all 3 sides in each triangle are marked off with congruent symbols. So we can see triangle ABC is congruent to triangle EDC by side, side, side there. So if we need a hint, all sides are marked. And it's key to note that the sides that are marked should be corresponding. So AB and ED are corresponding sides, and those are the ones that are marked with the same congruent marking. So we're going to take a look at this picture here, this blank picture, and we're going to mark it off so that it also represents side, side, side. When we do a proof, we're going to mark it off based on information. Here, we're just going to mark it off because we want it to be side, side, side. So AB and CB correspond to one another, so those 2 sides would need to be congruent. AD and CD would correspond to one another, and they would need to be congruent. And then finally, BD would need to be congruent to itself, and now this is another depiction of side, side, side. All right, our next example is side, angle, side. When we read this, notice the word angle is in between the 2 sides, and that's key of what you're going to look for in the picture. So we need the angle to be between the 2 sides. And when I'm referring to this, I'm talking about the angle that is marked off with the congruent symbol and the sides that are marked off with congruent symbols. So if we look at this first example, here's the angle, and you can see it's right between the 2 sides that are marked off. And the other triangle should have the same marking. They should always match. Okay, so we see the angle is marked off between the 2 sides. We're going to illustrate side, angle, side in this picture as well. So let's actually start off with an angle. Let's say that we knew that angle A and angle C were congruent to one another, and we want this to be side, angle, side. Well, I need the surrounding sides to then be marked off, so it would look something like this. So AB and CB congruent, and then the 2 at the bottom, AD and CD. Next, angle, side, angle is basically the reverse. So we want the side to be between the 2 angles. And if you look at our first illustration of that, you could see here's the angle that's marked off, here's the side marking, here's another angle marking, and the side is right between them. You could also think about it like they're all in a row. All right, if we make a angle, side, angle example in our picture, let's say I use these angles A and C. Let's say I use AD and CD as the sides, and I'll use the angles that appear to be right angles here. So here's another example of angle, side, angle. It's important to kind of keep in mind that when we're drawing them ourselves in this last column here, there's many right answers that we could draw. We're just drawing one possible illustration of each method, in this case, angle, side, angle. All right, next, angle, angle, side. We need the side to not be between the 2 angles now. So notice the similarity between the last 2. Right? Angle, side, angle, 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 side. They sound very similar. They both have 2 angles and 1 side. So the difference is where that side is located. So if I look at this example here, here's an angle, here's the side. The side that is marked off is not directly between the 2 angles that are marked off. That's what makes this angle, angle, side. Okay, let's add our own picture here. So I'll mark off the same angles from the previous one, But instead, let's say I mark off BD as congruent to itself. So here's angle, angle, side. All right, for our last one, it sounds a little different than all the others, right? We have different letters here. We have H and L. So hypotenuse-leg. It's important to realize that hypotenuse only exists in a right triangle. And you're going to see when we write proofs that we have to specify that before we use hypotenuse-leg. So only right triangles have a hypotenuse. That's the side that's across from the right angle. It's the largest side of the right triangle. And either of the legs would have to be congruent. Okay, so in a right triangle, you have two legs and one hypotenuse. We're looking for the hypotenuse marked off and one of the legs. So if we take a look at the picture here, is it a right triangle? If I look at ABC, yes it is, because I see the right angle there. Here's the hypotenuse. It has congruent markings. And here's a leg that has congruent markings. So this is our example of hypotenuse-leg. Using this example, I need it to be a right triangle. So we're going to put the right angles in. I need the hypotenuses marked off. And I need either legs marked off. So I could pick AD and CD, or I could pick BD. It doesn't matter, so we'll just pick one. I'll pick BD in this case. So I have the right angle, making it a right triangle. I have the hypotenuse, and I have a leg marked off. So those are our 5 methods by which you can prove triangles are congruent. If you are looking at a diagram and you do not have one of these methods, okay, there's a couple things there. It could mean that you marked something off incorrectly, or it could be you just don't have enough information for the triangles to be proven congruent to one another. Let's take a look at how we're going to start to put this together. So it says for each question, mark off any pairs of corresponding sides or angles that we know are congruent. Can we get 3 parts of each triangle marked off? And then we're going to determine the method by which the triangles are congruent. So here's where we start to build everything together from proofs. So let's take a look at example 1. It says JK is congruent to NM. So let's go to our picture. Let's mark them off. Those are 2 segments, so we're going to put the little tick marks on them. Then I know JL is congruent to NL. Okay, again, I know that because it gave it to me, so I'm kind of like checking off that I've addressed these. And then it tells me L is the midpoint of KM. Well, we know midpoints split segments into 2 congruent parts, so that must mean KL and ML are congruent to one another. The goal is to always have 3 markings, at least 3, per triangle. So if I look at triangle JKL here, there are 3 markings. If I look at triangle NML, there are 3 markings. So that's good. Now we have to decide which method from the front page. So is it side, 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 angle, side, or so on? Well, in this example, all 3 sides are marked off in each triangle. So triangle JKL is congruent to triangle NML by side, side, side. All right, number 2. HT is parallel to AM. Well, that tells me I'm going to get alternate interior angles. Remember, when you have alternate interior angles, they are formed by parallel lines and a transversal, and they kind of look like this Z shape in a diagram. It also tells me H and A are congruent. Notice it doesn't tell me it's a right angle, so I'm not going to put the square, I'm going to put the curves. Okay, I'm not going to assume it's a right angle unless I get that perpendicular indicator. And I mentioned before that there's always 3, or the goal is to get 3 markings per triangle. And if you look in this diagram, I only have 2 right now, and I've addressed all of the givens. I've done the parallel lines. I've worked with these congruent angles. That's where we need to start looking for other things such as the reflexive property, vertical angles, isosceles triangle theorem. And in this case, I can apply the reflexive property because I know TM is congruent to itself. So I can mark that off. And now when I look at my picture, I have 3 markings per triangle, and the triangles are congruent by angle, angle, side. Okay, there are 2 angles marked off in each triangle, and the side marked off is not between them. Number 3, KM and JN bisect each other. Well, that means they're both split in half. So KM is split into two congruent parts. JN is split into two congruent parts. And again, we're looking at this like, wait, there's only two markings per triangle. So let's take a look at what other things we could add in. I don't have reflexive property here, but I do have vertical angles. If the lines are bisecting, that means they're intersecting, and intersecting lines form vertical angles. Now I have my 3 markings per triangle, and this is a depiction of side, angle, side. Again, I know side, angle, side because 2 sides are marked off in a triangle and the angle between them. All right, number 4, BD is perpendicular to AC. Well, that always tells me about right angles. D is the midpoint of AC. That means I have 2 congruent segments. And I have another example of the reflexive property here. So number 4 is also an example of the triangles being congruent by side, angle, side. Again, there are 2 sides marked off in the triangle and the angle right between them. Okay, number 5, PQ is perpendicular to QS and TS is perpendicular to SQ. I'm going to address those at the same time. That just indicates the right angles are not adjacent, and I'm going to mark them off in the picture. If QS bisects PT, that means PT is what's split in half or divided in 2. So I'm going to take PT, look at the 2 halves, and mark them off. And then I have vertical angles here. And now I can pick my method because I have 3 markings in each triangle. So I have 2 angles marked off in a triangle and a side that's not between the 2 angles. So that is angle, angle, side. Okay, and for our last example, BD bisects angle ADC. So ADC is over here on the right. We're going to split that in half if it's bisected. And we also know DB bisects angle ABC. So this is split in half. BD is congruent to itself by the reflexive property, and I have my 3 pieces here. I have 2 angles marked off, but the side is between them. So this is an example of angle, side, angle. Hopefully this video helped you better understand how to recognize the 5 methods of congruency.